Okay, with this problem, of course this is a separable equation, but sometimes it's quite hard for you to separate x and y out of each other. But this one, of course, this is a separable equation. Now, let's take a look at this term and this term. Do you have x for this term? So you can take it out. This term and this term, you have negative 2. So you take negative 2 out. Oops, sorry. Plus 1. Right? Now, from 4 terms, you've got only 2 terms. And these 2 terms, you have y plus 1 for both of them. So you take y plus 1 out. So what you have left? X minus 2. Is it a separable equation? Yes, it is. Gx is equal to x minus 2 and py is equal to y plus 1. So in this case, the way that we solve for the solution of this type of differential equation, of course, you need to use the separable equation, because this is the simplest technique that you can use. Okay. The way that you're going to do it is put the function of y, which is y plus 1, to dy side, and put x minus 2 with dx side. Okay. So this one, we are going to move dx to the right hand side and put y plus 1 to the left hand side. So we would get and then you do integral for both sides. So you would get, what is the result of integral 1 over y plus 1 dy? Ln y plus 1. But this one, you can do like, you can take a look at x minus 2 as one term, and then you put dx as the x plus x minus 2. Or you can do separate them out like this. What would you get for this term? X squared divided by 2 minus 2x plus 3. So that is the answer. But can you just answer like this? No, because the problem statement asking you to find a solution which is satisfied with this boundary condition. This boundary condition saying that at x equals 0, y is equal to 1. From this boundary, you would be able to find the c number. Okay? So you plug y is equal to 1 there, you would get ln 2 equal to x equal to 0, 0 minus 0 plus c. So your c is equal to ln 2. So your answer would be ln y plus 1 equal to x squared divided by 2 minus 2x plus ln 2. That's the answer. Another example. Why give you guys a lot of examples? Yes. With this equation, it a separable equation? Is it a separable equation? If you want to know whether it is a separable equation, the way that you do is just that write down the dy by dx and see the right hand side is in the form that you can take x and y out of each other. If you can, then that is called separable equation. Can we? Can we do that? Can you do that? Actually, I can. Okay. If you don't know what to do, just start to write in the term of dy by dx first. Okay, so you get 2x to the power 3 y to the power 2 plus x to the power 3 y to the power 4 dy is equal to, we move the x to the right hand side, we would get negative of 3x square y minus xy dx. Okay, and then we would get dy by dx is equal to, I don't like to write a negative in the front, so I just did the negative term in there, so the back term here, xy would be positive, so I would get this. Okay, this one, we have y here and y there, so we can take y out of the x for sure, right? Because we have only one y for each term. So I take y out. This one I have x to the power 3, the same. So I take x to the power 3 out. Now, if you see this, of course, I can take y out of this term too. But the thing is that I just want to arrange in such a way that I can take y and x out of each other. And this one, I can take it, I can separate them apart. See, this term we have y only, this term we have x only, this term we have x only, and this term we have y only. So in this case, I would say that our gx is equal to x minus 3x squared divided by x to the power 3. And our py is equal to y divided by 2y squared plus y to the power 4. So that means if I want to do the integration, I can put y to the y and put x to dx, and then I can do integral right away. Because now I don't have x and y together. I can separate both of them out from each other. Okay. So then I would say I move y to the side of y, I would get 2y squared plus y to the power 4 divided by y dy equal to x minus 3x to the power 2 divided by x to the power 3 dx. With this, I can do dividing of each term by separate them first. I would get something like this. This term, 2y squared by y, is equal to 2y, right? This one, y to the power 4 divided by 5, y is equal to y to the power 3. X divided by x to the power 3 is equal to 1 over x squared. 3x squared divided by x to the power 3 is equal to 3 divided by x. And then now I can do integral. And using the integral property, I would get that's it. So integral 2y dy is equal to integral 2y dy is equal to y squared. Integral y to the power 3 dy is equal to y to the power 4 by 4. Integral 1 over x squared dx is equal to minus 1 over x. Integral 1 over x dx is equal to ln x. Since this problem didn't give you any boundary condition, so you just can answer like this, plus this. But if the problem statement gives you that your answer is got to be satisfied with one boundary, then you got to find the value of c by putting the boundary condition that problem statement given to you in your solution.